Now, let us understand the concept of remainder theorem. Now, remainder theorem states that let p of x be any polynomial of degree greater than or equal to 1 and a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. If I have to put it in a simple way, if I have, for example, any polynomial, let's say p of x is equal to x cube minus 3x square plus 4x minus 1. If I divide this by x minus 1, for example, so when I put the value of x as 1 here, so the value which I get after putting x equal to 1 is my remainder. If the value had been here x plus 1, then I would put x is equal to minus 1. So simply what you do is you have to put x minus 1 equal to 0. So whatever value of x you get, you have to just put that value of x here. Whatever that p of a you will get, that will be the remainder of the given polynomial. We'll take questions to understand this concept better. Once we do the question, the concept will get more clear to you. So let's take a question. So we have taken a question here. If p of x is equal to x cube minus 4x square plus 3x plus 7 and g of x is equal to x minus 2. So we are supposed to divide this polynomial by this polynomial. So let's directly go for the remainder theorem first. So because I have here x minus 2, I will take here x is equal to 2. So p of 2 is equal to, wherever I have x here, I will replace that with 2. So it will be 2 cube minus 4 into 2 square plus 3 into 2 plus 7. So it will be 8 minus 2 square is 4, 4 into 4 is 16 plus 6 plus 7. So this will be minus 10, this will be minus 2. So this entire thing will be 5. Let's just check it one more time. 6 plus 8 is 14, 14 plus 7 is 21, 21 minus 16 is 5. So the remainder for this expression when divided by x minus 2 should be equal to 5. Now to verify that, we'll go for the long division method. So let's just do that. So we have here x cube minus 4x square plus 3x plus 7. Now this is called the dividend. So whatever I write here is called the dividend. And then here we have x minus 2 as our divisor. So now to do the long division method, first understand you have to get the first, every time the first term eliminated. For simplicity, always write them in the decreasing order of the powers, and we try to eliminate always the first term. So to get x cube, what should I multiply here? I should multiply x square. So when I multiply x square, this will become x square into x is x cube. X square into minus 2 is minus 2x square. Be very careful with these signs. Now we'll flip the signs of both. Basically we are subtracting them. So if it was plus, it will become minus. If it was minus, it will become plus. So that's how we eliminate this. Minus 4 plus 2, that will be minus 2x square plus 3x plus 7 as it is. Now we have to eliminate this minus 2x. So we will multiply this by minus 2x. So minus 2x into x will be minus 2x square. Minus 2x into minus 2, that will be equal to plus 4x. Again we repeat the same procedure and we flip the signs. This gets cancelled. 3 minus 4 will be minus x plus 7. Now I need just minus x here, so I will multiply with minus 1. So this will become minus x, minus into minus, plus 2. Again we flip the signs, so we get 5 as the remainder. So here we can verify this, that in both the case the remainder is same, so hence verified. So this is how you can use the remainder theorem to get the remainder, and this is how you can use the long division method to get the remainder. Now let us understand the concept of factor theorem. Now in case when we use the remainder theorem and the remainder comes out as 0, then we say that the given polynomial is a factor of the mentioned polynomial. So in this case, for example, if we take identify whether x plus 1 is a factor of 2x cubed plus x square minus 2x minus 1. So simply what we do is we put the value of x as minus 1. So here we'll calculate the value of this polynomial with x equal to minus 1. So let's just take it minus 1 cube plus minus 1 square into minus 1 into minus 1 here. Always remember, you just simply have to do one thing. If it is x plus 1, I have to just reverse the sign. So x is equal to minus 1 I have to put for the entire polynomial. So here we get minus 1 cube is minus 1. So this comes out minus 2. Remember, minus 1 square is 1. Most of the times kids make a mistake and they take minus 1 as it is for the whole square. So it is 1 here plus 1, minus into minus is plus, so plus 2 minus 1. We can strike this off, we get the answer as 0. So because the remainder here is 0, we can say x plus 1 is the factor of the given polynomial. Now usually the question that comes in the exam is identify if this is the factor of the given polynomial. If yes, factorize completely. When you're supposed to factorize it completely, then we have to go for the long division method. So let us do it again. So here it is 2x cubed plus x squared minus 2x minus 1. We divide it with x plus 1. So we multiply this with 2x squared. So 2x squared into x is 2x cubed. 2x squared plus 1 is 2x squared. We flip the signs and we get this gets cancelled and we get here minus x squared minus 2x minus 1. Now I need here minus x squared, so I will multiply with minus x. This will be minus x squared, minus x into minus 1 is minus x. Again we change the signs and we get here minus x minus 1. We just multiply this with minus 1, so we get minus x minus 1. Flip the signs, we get 0 as the remainder. Now because we got 0 as the remainder, we are sure that x plus 1 is a factor of the given polynomial. Now we have to factorize it completely. So because it is a cubic polynomial, we will have 3 brackets as the factorized answers. So we will say p of x is equal to x plus 1 into 2x squared minus x minus 1. So x plus 1 will be this only. Now we have to split the middle term. That is, we have to find two numbers in such a way when we multiply them we should get minus 2x squared, and when we add them we should get minus x. So my terms will be 2x squared minus 2x plus x minus 1. Splitting the middle term concept is very important for your 9th, 10th and further standards as well. So please practice it very well. So we can just proceed with, from these two we'll take 2x as common. So we get as x minus 1. From these two, because there is nothing common here, we'll take plus 1 as common and x minus 1 is my other bracket. Now if these two brackets you don't get it as the same brackets, that means we have made some mistake in identifying the factors for the middle term. Now because these two brackets are same, of course there is no problem in solving this. So we get this as x plus 1, x minus 1 we take common and we get 2x plus 1. So this will be my complete factorized answer for this polynomial. In this way you can solve more questions based on this method.